Hello student, myself Jyoti Singh, chemistry teacher of Shivaji Group of Institute. In previous audio, we did the revision of part 1 of surface chemistry, that is adsorption. Now today I am going to start part B of this chapter, that is catalysis. In catalysis, first I want to explain what is catalyst and what is catalysis. So what is catalyst? Catalysts are those chemically compound which can able to change the rate of reaction. What is the meaning of rate of reaction? It means speed of reaction. Generally we choose those chemical compound which increases the rate of reaction. So also say that catalysts are those chemically substances which increases the rate of reaction or change the rate of reaction, and the whole process is known as catalysis. The mechanism process of catalyst in which it catalyzes a reaction, it means it increases the rate of reaction or change the rate of reaction, is known as catalysis. Remember, catalysts are those chemically compound which change the rate of reaction, but they does not consume in chemical reaction. It means at the end of the reaction these substances are recovered. Their physical state may be changed, but their chemical composition does not change. For example, decomposition of potassium chlorate is done at 360 degrees Celsius temperature, in which oxygen gas is formed, but the same process is proceed in the presence of powdered MnO2. In the presence of powdered MnO2, same decomposition is done at 250 degrees Celsius temperature. See the difference between temperature. In the absence of MnO2, decomposition is occur at 360 degrees Celsius temperature, and in the presence of MnO2, KClO3 gives O2 at 250 degrees Celsius. So here what do MnO2? MnO2 decreases the activation energy for this reaction, and also say that MnO2 increases the rate of reaction. MnO2 speed up the rate of reaction, speed of reaction. So for this reaction, MnO2 act as a catalyst. I hope you understand well what is catalyst and catalysis. After this, I will going to explain types of catalyst or catalysis. Student, here there are two type of classification. First classification is based on the physical state of catalyst and reactant, in which homogeneous and heterogeneous catalysis are present. And in second type of classification, which is based on the working process of catalyst, in which catalyst may be positive, negative, auto catalyst and induced catalyst. So we move to first type of classification, which is depend upon the physical state of catalyst and reactant. So what is homogeneous catalysis? Homogeneous catalysis or catalyst are those catalysts in which the phase is equal to 1 of reactant and catalyst. What is the meaning of phase? Phase is equal to 1. It means we cannot visually identify the presence of component in same mixture. For example, we cannot visually identify the presence of sugar in glass of water. So it means the mixture of sugar plus water have phase is equal to 1. But the mixture of oil plus water, both have liquid, but it does not have phase is equal to 1, because we can easily identify the presence of oil in water. So phase is equal to 1 when we cannot visually identify the component present in one mixture. So when phase is equal to 1, That catalyst is known as homogeneous catalyst and the process is known as homogeneous catalysis. For example, formation of SO3 in lead chamber process. In this reaction, sulfur dioxide react with oxygen gas to form SO3 in the presence of NO gas catalyst. Here reactant and the catalyst are in same phase. And in heterogeneous catalysis, when phase is equal to 2 or more than 2, it means when the reactant and the catalyst are not in same phase, then the catalyst is known as heterogeneous catalyst and the phenomena is known as heterogeneous catalysis. For example, in the formation of ammonia by Haber's process, in this reaction, N2 react with hydrogen gas in the presence of iron catalyst, MO also taken, molybdenum also taken, which act as a catalytic promoter to give ammonia. In this reaction, N2 and H2 are gases and Fe catalyst are in solid phase. So when the reactant and catalyst are in different phase, when phase is equal to 2 or more than 2, then the catalyst is known as heterogeneous catalyst and the process is known as heterogeneous catalysis. Now we move to second type of classification in which is based on the working process of catalyst. Number one is positive catalyst. Positive catalysts are those catalysts which increases the rate of reaction. There are several examples are here. For example, formation of ammonia by Haber's process, oxidation of sulfur dioxide. So in those reaction in which catalyst increases the rate of reaction is known as that particular chemically compound is known as a positive catalyst and phenomena is known as positive catalysis. Now next is negative catalyst. Negative catalyst is just opposite to positive catalyst. Positive catalyst increases the rate of reaction, so negative catalysts are those catalysts which decreases the rate of reaction. For example, tetraethyl lead decreases the knocking reactions in automobile, so tetraethyl lead act as a negative catalyst. Another example is addition of alcohol in chloroform, because in the presence of air and sunlight, chloroform oxidizes into poisonous phosgene gas. To prevent this reaction, we add some alcohol in it because alcohol act as a negative catalyst for particular this reaction. That is the oxidation of chloroform. Okay. Number third is auto catalyst. Auto means self. When in a chemical reaction, one of the product act as a catalyst. As increases the concentration means quantity. As increases the concentration of that particular product, as increases the rate of reaction. For example, hydrolysis of ester. When ester is hydrolyzed in the presence of H plus ion, it gives acid and alcohol. Acid is dissociate into carboxylate ion, that is RCOO minus and H plus ion. So as increases the concentration of acid, as increases the concentration of H plus ion. So here H plus ion act as a auto catalyst, and this reaction, this phenomena is known as auto catalysis. Now next one is induced catalyst or catalysis. Induced means motivate. In this type of catalysis, one of the reaction act as a catalyst for other reaction. Reaction catalyzed other reaction. For example, oxidation of sodium sulfite in the presence of air, it oxidizes, it gives sodium sulfate, Na2SO3. After oxidation, it gives Na2SO4. But oxidation of sodium arsenite into sodium arsenate is not possible. But when we do oxidation of sodium arsenite in the presence of sodium sulfite, both are oxidized. It means sodium sulfite Na2SO3 oxidizes into Na2SO4, as well as sodium arsenite Na3SO3 oxidizes into Na3ASO4, that is sodium arsenate. So here oxidation reaction of sodium sulfide to sodium sulfate induced the oxidation reaction of sodium arsenite. So oxidation reaction of sodium sulfide to sodium sulfate act as a induced catalyst, and this phenomena is known as induced catalysis. So we done the catalysis, types of catalyst or catalysis. Student, I give you some questions which are based on this explanation. I hope you do well. Thank you.